Welcome back to my online chemistry tutorial. Today I discuss you about two important reactions of carbonyl compound. One is Wittig reaction and another one is Cannizzaro reaction. So first one, Wittig reaction. Wittig reaction is reaction of carbonyl compounds like aldehyde or ketones with the phosphonamylate to form alkene. So final product is alkene. So reaction of carbonyl with the phosphonamylate. Actually, this is the different one that we have seen in my previous tutorial. Here carbonyls are reacting with the phosphonamylate. So what is phosphonamylate? Actually, phosphoramylate is a species with a positive and negative charge on adjacent atoms. Here, ylide phosphonamylate means the positive charge is on phosphorus atom. And this reaction is named after the scientist Wittig. So this is the general reaction, carbonyl with the phosphonamylate. It forms alkene and triphenyl phosphoname oxide. In overall, the reaction carbonyl bond is substituted by C double bond C. So coming to the mechanism of Wittig reaction, first case the preparation of phosphonium ylide. In first step, triphenyl phosphane react with alkyl bromide. It is a nucleophilic substitution reaction. Triphenyl phosphine can act as a nucleophile, and alkyl halide can act, so this carbon can act as an electrophile, and this nucleophile substitute this bromine and it forms phosphonium salt. And this phosphonium salt it forms. And in presence of very strong base, that is phenyl lithium or butyl lithium or sodium hydrate, this hydrogen, this is acidic, and this hydrogen get deprotonated and it form this phosphonium ylide salt. And this is a resonance hybrid structure, and the first one, the resonance hybrid, is having more contribution, and second one is having less contribution in actual structure. So most of time the more contribution is from this structure. Structure will be more resembled to this first one. So next one, reaction of this carbonyl compound with the phosphonium salt. And here this carbanion can act as a nucleophile, and carbonyl, of course, will be an electrophilic center. So this nucleophile attack the carbon, then double bond break, and it form an intermediate, oxonium intermediate and phosphonium P plus and O minus, and it form a bond, and cyclic structure will be formed. And this cyclic structure, of course, it is highly unstable, so it decomposes like this. Actually, decomposition will be, the phosphorus will be having more affinity towards the oxygen, because PO bond is actually, this PO bond is very strong bond. So there will be driving force for the formation of, for the decomposition like this, and it form an alkene and phosphorus oxide like this. Example for Wittig reaction, cyclohexanone, and treating with the phosphonium salt, it form as compound like this. Here you can see the carbonyl is converted into C double bond C. This carbonyl, instead of oxygen, carbon comes here. So this is the overall changes that occurs during a Wittig reaction. So we also can make, this is the mechanism of formation. First, phosphonium salt will be formed, then in presence of base, halide form, then with carbonyl, it form alkene. So this alkene can also be synthesized. There is a recent method to make this alkene. But the recent method, you can use cyclohexanone with methyl magnesium iodide, and it forms a compound like this. This is on dehydration, you get a mixture of product. So to get this compound, actually this method having limitation, because it can give main product will be this one, first one. You get only very small quantity of actual product. So this is not a good method to make this compound. So Wittig reaction is the best to make this compound. And if you're having in Wittig salt, if you are having minus M group, like here, for example, cyano group, this will be phosphorine, will be highly stabilized. And this can react readily with aldehyde. This halide can react readily with that, but not with ketone. But this reaction has been modified by Wordsworth-Imans. That reaction is known as Wordsworth-Imans reaction. Actually, what he has done is he has used triethoxyphosphorus instead of triphenyl phosphate, and he was able to react this phosphonium salt with ketone, and he obtained the final product alkene. This is a modified Wittig reaction. An application of Wittig reaction. Wittig reaction can be applied for the synthesis of vitamin A1 acetate, which can be started. This compound can be started from this phosphonium salt. In presence of base, it forms an halide, and this halide can react with electrophilic center aldehyde, not with ketone. And with this aldehyde, it forms a compound vitamin A1 acetate, and an unsaturation occurs at this center. This further development in this direction is you can also introduce aldehyde group into this carbonyl compound. If you are using an Wittig reagent or phosphonium salt like this, here what is the difference? You have an OMe here, so you get a compound like this. Then finally on hydrolysis you can get aldehyde here instead of, or you are getting in this reaction CHO. And you can use bifunctional Wittig reagent. Here you have bifunctional Wittig reagent. There is two phosphonium salt it has, and this can be function as at two position, at two aldehyde position. Then this react with this carbonyl, and this one will react with this carbonyl, and it form finally a cyclic structure like this. Unsaturated bond will be formed here. Next one, Cannizzaro reaction. It is also called Cannizzaro disproportionation reaction. What is Cannizzaro reaction? It is an aldehydes, like aromatic aldehyde or aliphatic without alpha hydrogen atom. That is important. Without alpha hydrogen atom can undergo a redox reaction in the presence of very strong base. and it gives alcohol and carboxylic acid. So carboxylic aldehyde in presence of base, you get a mixture of acid and alcohol. One case aldehyde undergo oxidation, in another case it can undergo reduction. For example, as aromatic aldehyde in presence of base, it give, if it is benzaldehyde, you get benzyl alcohol or benzoate, sodium benzoate. So in all cases, one aldehyde oxidizes other into acid, and at the same aldehyde itself reduced to alcohol. Coming to mechanism, the mechanism is not unclear, but the proposed mechanism is like this. Generally speaking, we can say any carbonyl compound, aldehyde in presence of base, what happens? A nucleophilic substitution take place. Then OH will react here at this carbonyl position, double bond break, and it form an intermediate like this. And in presence of high concentration of a base, it form dianion. So one pathway for this reaction is this first one will react with another carbonyl, and in this case, this compound is unstable. It will try to stabilize and it form a double bond, and when it formed a double bond, either of this H minus or R minus or OH minus has to be moved from here. So which is the best leaving group among these three? That is H minus is actually best leaving group. So H minus, there will be hydrate transfer, and that hydrate H minus can be attacked to a carbonyl, another carbonyl, and it form an actually an alkoxide, and other one become a carboxylic acid, and it can undergo an acid base reaction, and this acid will be stabilized by making carboxylate, and this will RCH2O minus, it become alcohol. Next one, another pathway, this dianion that can be added to carbonyl, dianion. And dianion, the same reaction take place, hydrate transfer take place, and this become C double bond O, this becomes C double bond O, and this will become O minus, then this will become H will come here, and O minus, it will be O minus. So alkoxide and carboxylate product you get. And acid workup, finally you get acid and alcohol. For example, this compound, naphthaldehyde in presence of base, this carbon aldehyde get oxidized in one case, and in another case it get reduced. And cross Cannizzaro reaction. In cross Cannizzaro reaction, formaldehyde, if you are using formaldehyde in presence of base, first it will form, the base will attack formaldehyde, because formaldehyde is more reactive towards the nucleophile. Actually, nucleophile is more reactive towards the formaldehyde if you are using any other aldehyde. So OH always attack formaldehyde. Then this one, hydrate transfer take place to second aldehyde. So always you get acid in the case of formaldehyde. If you are using formaldehyde and any other aldehyde, it can undergo cross and Cannizzaro reaction, but what does undergo oxidation? Always formaldehyde can undergo oxidation, and other case, other aldehyde become alcohol. For example, benzaldehyde and formaldehyde, if you are using, always formaldehyde become acid, sodium formate, and benzaldehyde become benzyl alcohol. This is the one problem you have to do. So the product will be like this. Thank you for watching.